Good morning, everyone. Today we're going to talk about inequalities with absolute value. Now, if you recall, last week we went over the fact that if I told you that the absolute value of x was equal to 2, then x could have been a positive 2, but it also could have been a negative 2. If you plug in negative 2 right here in the absolute value of x, you take the absolute value of negative 2 and it's positive 2. So anytime you have an inequality that has an absolute value with it, keep in mind that we're going to have two different directions going on because it could have been positive, it could have been negative. So if you look on page 432, we have 102.1 says the absolute value of x is greater than 2. All right, so that means that the distance from 0 has to be bigger than 2 because by definition, absolute value is the distance measured between the origin, which is 0, and that number. So what this is saying is that the distance from 0 has to be bigger than 2. So the way that you would write this is you'd write it just like this without the absolute value, greater than 2, or x is, write the symbol the same and put negative 2. That takes care of this part of it. We don't know whether it was positive or negative. So now when you graph that, some people have a hard time reading it in this form. So you can switch it and make it x is less than negative 2 or x is greater than positive 2. And we're supposed to graph this. So on a number line, we've got 0, 1, 2, negative 1, negative 2, and I'll go ahead and put an extra number on here. So x is greater than 2. That means 2 is not included, so we put an open dot on 2. And which numbers are greater than 2? Well, all the numbers to the right are greater than 2. Which numbers, let's see, x is less than negative 2, so we put an open dot on negative 2. And which of these numbers are less than negative 2? All the negative numbers going to the left. So this is a distance that's greater than 2 from 0. So if you go back and look at it, here's what we were trying to accomplish. Absolute value of x is greater than 2. So in other words, another way of thinking of this would be the distance from 0 is greater than 2. So here's 0. The distance from 0 has to be more than 2. So we go out 2 units and everything greater than that. On the other side, we go out 2 units right here and everything that's farther than 2 units from 0. So there's the answer to that one. Anytime that you have an absolute value of x greater than a number, you'll have to use this technique to solve it. The next one is different because it says absolute value of x is less than or equal to 3. Now this one is saying that the distance from 0 has to be less than or equal to 3. That's called a conjunction when it comes together. This one is a disjunction because it goes apart. It goes away from each other. A conjunction comes together. So it's going to be either open dots like this or closed dots like this where they come together. That's a conjunction. And the difference is in the symbol. This symbol is a conjunction. This symbol, the greater than or equal to, is a disjunction. So they go away from each other. So in this one, I'm just going to come down. I'm going to write it just like it is. And I'm going to copy this symbol right here because a conjunction can be written together. And instead of writing positive 3, I'll write what kind of 3 on this side? Negative 3. And so we graph exactly what it tells us. Greater than or equal to negative 3. So what kind of a dot do I put on negative 3? If it's equal, it's a solid dot. Okay, greater than that's coming this direction. And then less than or equal to a positive 3, so it's equal also, so it's a closed dot. And the numbers less than 3 are going to come this way. So we just draw the line until they meet. So any number that you plug in here, like if you picked 0 and put it in for x, right here, absolute value of 0, is that less than or equal to 3? Yes. Any of these numbers that you plug in would give you an absolute value less than 3. Okay, next on page 432. Absolute value of x is less than negative 4. All right. I want you to think about what you know about absolute value. Absolute value is always what kind of a number? If I drive to Artesia, I drive 42 miles. If I drive back from Artesia, is it a negative 42 miles? No, it's not. It's just 42 miles. So absolute value is always going to be a positive measure. Okay, always. So what kind of numbers are less than negative 4? If we look at it on a number line, what kind of numbers are less than negative 4? They're over here. What kind of numbers are these? They're all negatives, right? So now you tell me what absolute value is going to be less than a negative number. In other words, what absolute value is going to be a negative number? There are none. So this is simply draw the line with nothing on it, or write no solution. There isn't a number that you can plug in here that's going to give you a negative number. So there are no numbers that will give you an absolute value less than negative 4. Now, if we turn that around and we make it absolute value of x is greater than negative 4, so look on the number line. Here's negative 4. Here's all the numbers that are greater than negative 4, to include, let's say, zeros here. All the positive numbers are over here. So every positive number is greater than negative 4, isn't it? So you can plug in any number for x, and it'll give you an absolute value that's greater than negative 4. Try it. Try negative 1,000 if you don't believe it. What's the absolute value of negative 1,000? It's 1,000. Is that greater than negative 4? Yes. Any number you plug in for x will give you a number greater than negative 4. So the solution to this is you graph the entire number line, or you write all reals. Every number will work. So basically, when you have a problem like this, if you end up with an absolute value and you have a negative number on the other side, it does not matter if it's less than or it's greater than. You know it's a special circumstance. Okay? If it's absolute value and it's less than a negative number, it's no solution. If it's an absolute value and it's greater than a negative number, then it's going to be all reals. And that works too if it's less than or equal to or greater than or equal to. Okay, so that holds fast for those two. It doesn't matter if it's negative 4 or negative 1,000 or negative 6. It doesn't matter what the negative number is. As long as this is a negative number, this applies. Okay, let's go on. Now, 102.5 says minus absolute value of x is greater than or equal to negative 3. Well, we can't have that negative absolute value of x. So how do we get rid of the negative? It's multiplied, so the inverse of multiplication would be division. So divide by a negative 1 on both sides. And remember, when we do divide by a negative, we have to flip this symbol around. So this will become less than or equal to, this is absolute value of x. Negative 3 divided by negative 1 is positive 3. Okay, so now if you look back at your notes, you'll see that when it's a less than, it's a conjunction. They're going to come together. So we can write it as x less than or equal to 3, copy this symbol in front, and change the number to a negative 3. Okay, that's because this symbol indicates a conjunction. So if I graph it, negative 3, negative 2, negative 1, 0, 1, 2, 3. I think this is the same as what we did just a few minutes ago. Let's see, less than or equal to, greater than or equal to, less than or equal to. So we're going to have closed dots on both of these. And the numbers are less than or equal to positive 3 and greater than or equal to the negative 3. So they just come together. That's what makes it a conjunction. All right, last example on this lesson. Graph minus absolute value of x minus 2 is greater than negative 5. Well, before we can do anything else, we need to get the absolute value of x on one side and the number on the other side. Okay, so we're going to add 2 just like we would if that was an equal sign. So that's minus absolute value of x greater than negative 3. And then we can't have negative absolute value of x. So we need to divide by a negative 1. Remember, that means that this guy has to switch around. Okay, the symbol has to switch when you're dividing by a negative. So negative divided by negative is a positive absolute value of x is less than negative 3 divided by negative 1 is 3. So the only difference in this one and this one is that it's less than 3, not less than or equal to 3. So we come over here, we can rewrite this as x less than 3 greater than, change the sign, it's a negative 3. And draw the number line, so we've got minus 3, minus 2, minus 1, 0, 1, 2, 3. And because it says greater than negative 3, it's an open dot. Less than positive 3, an open dot. Numbers greater than negative 3 come this way, and less than positive 3 come this way. So any of these numbers that you plug in for x will give you a solution to that. It'll give you a true statement if you actually plug it in right here. All right, that's all for lesson 102. Make sure that you grade that and upload it by class time on Wednesday morning. And I'll see you tomorrow. Thank you very much.